Okay. All right. So let's think about if we're talking about the tangent, right? We just said that it was sine x over cosine x. And if we look on the unit circle, okay, remember on the unit circle, cosine is always the x coordinate, right? So if I'm here, x is 1, y is 0. If I'm here, x is 0, y is 1. And here we're at negative 1, 0. Here we're at 0, minus 1. So if I'm at pi over 2, or if I'm at 3 pi over 2, the cosine there is 0. And that's really the only point, the only 2 points on the unit circle where the cosine is 0. All right? Now, it's fine when we're just talking about cosine. But when we're talking about sine over cosine, the points where cosine is 0 are going to give us issues. Because at these points, like at pi over 2, how much is the tangent? It's undefined, right? It's y over x undefined. At 3 pi over 2, tangent is y over x undefined. Now, if I go over, so that's pi over 2, 3 pi over 2. If I go to 5 pi over 2, I'm here again, and the tangent is undefined. 7 pi over 2, tangent is undefined, and so on. At every pi over 2, the tangent is undefined. All right? That means, right, since tangent of x is undefined when cosine is 0, at those points, there are vertical asymptotes. Okay? So this is when x is pi over 2, 3 pi over 2, and so on. And the same with negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. Okay? So at every at each of the pi over 2's, there are vertical asymptotes. So if we look at the graph for the tangent right here, it looks very different from the sine and cosine graphs, right? But if you notice, just like we said, there is an asymptote at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and if we continued this, it'll continue like this on both ends forever and ever and ever. Notice further that there are still cycles. That's 1 cycle, that's 2 cycles, and 3 cycles. A cycle is just a repetition, right? So it is still a periodic function with periods and cycles and everything else. So if one cycle goes from negative pi over 2 to pi over 2, how much of a distance is that? So we have half a pi here, another half a pi there. In total, we have 1 pi. So the period of the tangent now is no longer 2 pi, it's 1 pi. Okay? So we're going to remember that. That's different. Also, what is different is the beginning and end points of the cycle. For sine and cosine, it went from 0 to 2 pi. Now, for the tangent, it goes from negative pi over 2 to pi over 2. And the total period is just a pi. Okay? All right. The general form of the tangent function is this right here. You see how it looks very similar to the sine and the cosine? It's just that it's now a tangent. There are vertical asymptotes at each of the pi over 2's. How do you find the vertical asymptotes? Well, we solve these equations. So what we do is we take bx plus c, set it equal to negative pi over 2 and pi over 2, and we can figure out the asymptotes from there. Okay? All right, all this will come together soon. Okay, let's go step by step. Let's talk about the period of the tangent function. For sine and cosine, in order to find the period, we did what over what? 2 pi over b. It's because it was a period of 2 pi that we were cutting up. Now, the full period here is 1 pi. So for the period, we're just going to do pi over b. Okay? Remember, for sine and cosine, we were solving the inequality, from 0 to 2 pi of bx plus c, right? Here, in order to adjust for the period, we're going to solve the inequality from negative pi over 2 to pi over 2 bx plus c. Okay? So, for sine and cosine, it was 0 bx plus c 2 pi. Why did we do that? Because this was the start and end of that initial cycle. For the tangent, the start and end of the initial cycle are negative pi over 2 and pi over 2. Okay? When we do this, we magically also get the asymptotes. So, without further ado, let's just do one. And you'll see that it's going to be very similar to what we did before. All right, so here we want to find the vertical asymptotes, and we want to sketch y equals tangent 3x. Okay, how much is the period here? Pi over 3. And that's it. Okay, the asymptotes, we're going to do the asymptotes and the 5 points all together. So, let's solve this inequality. Negative pi over 2 less than bx plus c less than pi over 2. I'm going to go back here. I thought I had fixed this. These should not be inequalities. They should be, I'm sorry, it should not be less than or equal to. It should just be less than. Because there are asymptotes, it can't equal those points. Okay, so what do we put in the middle here for this equation? Just 3x. Is this familiar so far? Right? Very similar to what we did for sine and cosine, except the endpoints are different. Okay? And then, now for a little bit of algebra, divide by 3, divide by 3, divide by 3. What I get is negative pi over 6 x pi over 6. Now, that tells me 2 pieces of information. One, it tells me the start and end, like it did with the sine and cosine. 2, the first and last number are the asymptotes. Okay? So these are the asymptotes. I abbreviate asymptote as ASP. Okay? Question. When you do the sign, it would be... Remember that asymptotes are lines. And we need, for lines, we need equations. So it's never, the asymptote is negative pi over 6. It's x equals negative pi over 6. X equals pi over 6. If you want to abbreviate, you could say x equals plus or minus pi over 6. Okay? Now, what comes next is very similar to what we did before. Negative pi over 6, 1, 2, 3, 4, pi over 6. Sound familiar? Yes. In this case, there are asymptotes here. Please don't forget those asymptotes. I cannot give you full credit if the asymptotes are missing. Okay, now we need to find midpoints. The midpoint from the very beginning to the very end, right? We're going to do negative pi over 6 plus pi over 6 divided by 2. So what's the midpoint there? 0. And we know also that eventually that's where the y-axis is going to go. Now, this midpoint here, it's the middle between negative pi over 6 and 0. So I do half of negative pi over 6 plus 0. How much is that? Negative pi over, somebody said it. Negative pi over 12. Okay. And then what's that midpoint there? Just pi over 12. It's very symmetric. This one is very symmetric because tangent is symmetric around the origin. And if you don't have a phase shift, then tangent is going to be symmetric. Now I got my 5 points. And here's my y-axis. Yay. Okay. Now, what's tangent of 0? Okay, it's one or the other. Let's see. Back here, tangent of 0, this is where 0 is. Tangent is y over x, so 0. So tangent of 0 is always 0. Okay? Huh? At pi over 2. At pi over 2 is undefined. That's why there is a... Yeah. Because at 0, tangent is 0. Yeah, x is 0, y is 0 for tangent. Okay? Yeah.
Is the midpoint always going to start at 0? So like the midpoint,
No. Right. So now, look at this point. Look at this point here, pi over 12. How much is y when x is pi over 12? You know what? Let's just test it in this function. At x equals pi over 12, y is tangent of 3 times pi over 12. How much is that? Tangent of pi over 4. How much is tangent of pi? It's 1. So here it's 1. Okay, what is it going to be at negative pi over 12? Negative 1. Okay, I have a secret for you. Tangent is always going to be, right, like this. The center is going to be on the axis. Then it's going to be up 1, down 1. Unless there are any negatives happening somewhere, okay? So it's going to be up, maximum, and minimum. So now, remember there is an asymptote, and it's got to follow the asymptote here. And it looks like that.
So we only need to find 3 points?
It's never, yes. Well, no. We have 1, 2, 3, 4, 5 points. But the last and the first point are the asymptotes. It's never allowed to hit the asymptote, right? Because it's undefined at the asymptote. Okay? Okay. There are 1, 2, 3, 4, 5 critical points. And, okay, you put in 3 dots. Okay, 3 defined points. 5 critical points. Okay? All right, let's do one more. Let's do one more. What's the period here? It's pi over 1/3. So 3 pi. Okay? All right, so for the asymptotes, I'm going to do 1 over 3x, and we're going to go from negative pi over 2 to pi over 2 again. Right? Multiply everything by 3. Negative 3 pi over 2 to 3 pi over 2. So, on my x-axis, I got negative 3 pi over 2. 1, 2, 3, 4, 3 pi over 2. What's the midpoint, the very center of this? 0. Okay, what's that first one here? If this is negative 3 pi over 2, right? Then here, it's 0 plus negative 3 pi over 2. divided by 2. So it's half of negative 3 pi over 2 plus 0. That's negative 3 pi over 4. So this one is going to be positive 3 pi over 4. Man, I missed this stuff. It's been like a full year that I did them last time. Huh? Oh, we're going to do it a long time, like for a very long time. But like it's been, yeah, it's been a year. Okay, I just miss it. Okay, here we go. Asymptotes, asymptotes. Can we leave the asymptotes out? No. Okay. Exactly. I mean, you can leave it out, but not if you want full credit. So at the center, it's on the axis, and then it's positive in the front here, right? A is positive here. So we're going to go up 1 to the right, down 1 to the left. We follow the asymptote, and there. Yeah. These seem easier because you really are experts at the other stuff now. More than you think. You are expert at the sine and cosine now. So the asymptotes are going to be at x equals plus or minus 3 pi over 2. Okay. Take a look at this one. This time, let's talk about reflections and translations. Period is going to be how much here? Pi over 1/4, so 4 pi. Okay, so for the asymptote, it's going to be x over 4, and we're going to go from negative pi over 2 to pi over 2. I'm going to multiply everything by 4. So it's going to be negative 2 pi to 2 pi. Okay. Just to do, okay, so let me do this first. So we're going to go from negative 2 pi, 1, 2, 3, 4, 2 pi. Just to make sure you're doing things correctly, you're on the right track. How many units is it from negative 2 pi to 2 pi? 4 pi units. Is that what we got for the period? Yes, that should always be consistent. Okay? So, what are the asymptotes? So, x equals negative 2 pi and x equals positive 2 pi. Don't forget your asymptotes. What's the value? What's the midpoint? 0. I know. You know exactly where to put your y-axis and everything. In fact, let's do that now. And then, what's the midpoint on the, what's like the quarter point on the left? Negative pi, positive pi. Okay. Now, take a look here. A is negative 1. That means when I go to the right, I'm going to go down 1. 0, up 1. Because it's a negative in front. But now, what are the units? It's 1. Because A is negative 1, you go down the same value as A. Here in front, A is minus 1. Okay?
So also, why is this pi over 2? Why do you put pi over 2?
Because in the default case, that center cycle of the tangent goes from negative pi over 2 to pi over 2. Okay? So, look up here for a minute. Suppose you think it's too good to be true, that it's just as simple as go down 1 and go up 1. Well, let's try that. Let's try this point. That's x equals pi, right? At x equals pi, let's see what y will turn out to. Y is negative tangent of x over 4 here, right? So negative tangent pi over 4. Y is negative. What is tangent of pi over 4? 1. Negative 1. Because we are adjusting with the default period, no matter what, if you did it correctly, that first midpoint here between, the center and the asymptote, if you did it correctly, that point, when you plug it in, should always correspond to pi over 4. So the tangent is always going to be, 1, and then you have to multiply it with the 8. All right, so here, this will look like this and that. Okay? Okay, let's do an exciting one. This one here we have x plus pi over 2. Okay, so period is pi over 1, just pi. Asymptotes, we'll do it in a minute. Phase shift, same as before. I take that in the parentheses, set it equal to 0. X is negative pi over 2. Yes. Because it's always pi over b, and the number in front of the x here is 1, so it's pi over 1. Okay. Now for the asymptotes. We're going to go from negative pi over 2 to pi over 2. This time, in the middle, we put x plus pi over 2. Okay. Subtract half a pi. Subtract half a pi. On the right-hand side, we're at 0. Left-hand side, I never do negative pi over 2 pi over, look, I think of them as fractions, halves. Negative half pi minus another half pi. Half, 1 pi. So that's negative 1 pi. Negative pi. So now, negative pi, 1, 2, 3, 4, 0. How much is the distance from beginning to end? From negative pi to 0? You know. From negative pi to 0, how much is it? It's pi. Is that what we got for the period? Yeah. No, I'm saying the total distance. Oh, total. Right. Okay. So so first off, this is where the y-axis is, and there is an asymptote there. If you're using a pencil, like you could just go like slightly to the left or right, just make it visible. Okay. Midpoint, negative pi over 2. Huh? Sure. This is negative pi over 4. This is negative 3 pi over negative 3 pi over 4. If you're still confused on how to find those points, let's talk at bonus. Okay, now, center is always going to be on the 0. Okay? Look. To the right, look at what A is. Negative 1. I go to negative 1. And then I got to make it symmetric. And there. Yeah. Okay. Oh my gosh, that's perfect to stop here. Let's finish the lesson tomorrow, and then you'll do homework. If you want to